see about different types of the diodes. For that one, the introduction will be like this. We can able to tell, for example, the basic diode what we have seen previously is a PN diode. So di means 2 and ode is coming from the electrode. So that means 2 electrodes are available. 2 electrodes are available for all these types of the diodes. Then only we can able to treat that one is a diode. And it is the basic diode. For example, if you take one p-type layer, one n-type layer, in between these two, one depletion region is created. So this is the basic structure of the PN junction diode. This one already we have done. Now different types of the diodes we will see, and this PN junction diode is actually because of indirect semiconductor materials. So we have indirect semiconductor materials and direct semiconductor materials. The basic PN junction diode is fabricated or it can be made using indirect semiconductor materials. So in these indirect semiconductor materials, heat will be produced. But if you take the direct semiconductor materials, the light will be illuminated on that one. So we will be dealing with the light when we are working with the direct semiconductor materials. And we will be dealing with the heat when you are working with respect to this indirect semiconductor materials. And what is this one? It is the depletion layer created between two different regions. Those are p-type and n-type, or it can be n-type, it can be p-type. In between those two layers, the depletion region will be created. About that one already we have worked. Now, these are the different types of diodes we can able to take. Generally, diodes are offering the current flow in only one direction. Starting from p-n junction diode, if you observe, under the forward bias condition, we are getting the current through this particular PN junction diode, that is from p-type to n-type only. And there will not be any current flow from n-type to p-type, but a little amount of current is there, that is due to minority charge carriers whenever we have operated this one under the reverse bias. Reverse bias means we can able to give this p-type to the negative terminal and n-type to the positive terminal. If you can able to provide like this, we can able to tell that is under reverse bias, and this connection is indicating forward bias and this connection is indicating reverse bias. So because in the reverse bias, whatever the current we are getting, that current is due to minority charge carriers. Minority charge carriers are less in number. That means very less amount of current we are getting in the reverse bias. So orally we can able to tell there is a current flow in the PN junction diode from p-type to n-type whenever that is operated under the forward bias. So if you neglect the little amount of current from n-type to p-type whenever it is operated under the reverse bias, we can tell in only one direction the current flow is possible in the PN junction diode, that is whenever it is operated under the forward bias. That too from p side to n side only. That is the reason we are giving the diode circuit symbol like this. There is a triangle like this will represent that too from, it is indicating the current flow from p side to n side, and this vertical line is indicating there is no current flow from n side to p side. So this is a diode symbol we'll give for the PN junction. Okay. Now already I have mentioned that it is because of the indirect semiconductor materials, so we are not going to deal with the light here. But here we are seeing diodes allow current flow in only one direction, variations serve different specific functions. Okay, now we will see about photodiode, we are going to see about Shockley diode and solar cell and optocouplers. These are the different types of semiconductor devices we are going to see. Now we will start with the construction of the photodiode. Okay, so you see it is similar to our PN junction diode circuit symbol only. Okay, if you include this arrow, so this is a circuit symbol for the photodiode. Little bit change is there, you have to be more careful here. For example, if I indicate this is the semiconductor device, it is representing simply the PN junction diode only. It is simply PN diode. But whenever you are keeping the arrows which are indicating the light actually, okay, the light is incidenting on the diode junction, then we can tell it is not PN junction diode. Already I have mentioned that PN junction diode is because of the indirect semiconductor material. We are not going to deal with any light concept in this particular PN junction diode. But the circuit symbol is looking like same, but in addition to the same structure, here we are taking these two arrows. This is indicating that light is illuminated on this particular junction. So it is now not representing the PN diode, it is representing the photodiode. That is what you have to observe. So carefully you have to see the circuit symbol, what we are representing for PN diode and what we are representing for photodiode. If you see for LED, that means light emitting diode, the arrows will be going away from the diode structure. That means light is emitted from the diode. Okay, light is generated from the diode. That means arrows are going away from the structure. But in case of the photodiode, light is not going away from the diode. In order to operate this particular photodiode in a required region, what we are doing in the sense, we are incidenting the light on the diode junction. That is the main point here. Okay, so whenever you are talking about the photodiode, we need to incident the light on the diode. Okay, then the function of the photodiode will be performed. That is what we need to see. So here you can able to check that one. Anode is there, cathode is there, and light is illuminated on the diode structure. Then PN or pin junction diode operating in the reverse bias. So generally, if you see GNR diode, the purpose of the GNR diode is a voltage regulator, or we can tell the application of the GNR diode is a voltage regulator. But the operation of the voltage regulator for the GNR diode is done in the breakdown region of the GNR diode only. But GNR diode can be operated in the forward bias also, but it can be using as a voltage regulator. The purpose of the GNR diode can be done in the reverse bias only. So that even though we can able to operate in the forward bias, we are telling the operation of the breakdown, the operation of the voltage regulator can be achieved when the GNR diode is operated in the breakdown region of the reverse bias. So we need to keep that particular GNR diode in the reverse bias. Then only that can be working like a voltage regulator. Similarly, the photodiode also should be operated in the reverse bias mode for the intended purpose. For the intended purpose of the photodiode, we need to operate that one in the reverse bias. What about this PN and that means PIN junction? So the photodiode can be the PN layers only, like how the PN junction diode is there, how the photodiode structure is also available. That means one P layer, one N layer. Otherwise, pin model is nothing but P layer is there. Beside that one, intrinsic semiconductor we have to take. This I stands for intrinsic semiconductor and N stands for N-type layer. So P-type layer, intrinsic layer and N-type layer. Three layers are available in this particular model. So photodiode can be in the model of the PN, in the model of the PIN also. P-type, intrinsic and N-type. That is what we need to understand. And one more point is, it is to be operated in the reverse bias mode only for the intended purpose. Next, when light is incident on the depletion region, generates the EH pairs. What is the meaning of this one? Already I have told in the beginning itself, if you take LED, that means a light emitting diode, light is coming from the diode. When you operate the LED in the forward bias, light is coming from the diode, that means light is coming out of the structure of the diode. So arrows should be indicated away from the diode. But in case of the photodiode, we need to incident the light on this particular diode structure or on the depletion region which is created between P-type layer and N-type layer. So when the light is incidenting on the depletion region of this particular photodiode, then electron hole pairs will be created. What is this one? It is generating the EH pairs. EH pairs is nothing but, it is very important point here. The electron and hole pairs. Okay, what is this one? Electron hole pairs will be created when we incident light on the depletion region of the photodiode. Okay, the transparent window, thin P layer and N layer contact will be available. Okay, here already I have mentioned one P layer, one N layer will be there, and in between these two, the depletion region will be created whenever you have the different layers side by side. P, N. So definitely the depletion region will be created, and when the light is incident on that one, the electron hole pairs will be created in this particular contact. Whatever the contact is there in between P type and N type, in between them, we have the electron hole pairs generation will be available. Now, what are the materials will be used for the fabrication of this particular photodiode is nothing but silicon and germanium. Generally, those two are the semiconductor materials. So, not only by using the silicon, generally silicon is used in a more frequent manner compared to the germanium. But in the fabrication of this particular photodiode, we can use either silicon or germanium. Both will give the proper operation of the point only. Next, if you see this particular structure here, how the electron hole pairs are created, that was available in this particular diagram. Here you see incident photons. That photons is nothing but light only. So we need to incident the light on the depletion region of the this particular photodiode. Then, as per this particular statement, we can tell that electron hole pairs will be created. And whenever electron hole pairs are created, then current will be flowing through this particular diode. So we need to operate this one under the reverse bias only. You can able to check that one in the diagram also. This is P type, this is N type. Reverse bias means what? P is given to the negative terminal of the battery and N is given to the positive terminal of the battery. After giving this particular reverse bias, we need to incident the light. Photons means light, phonons means heat. It is also one of the important point. So generally phonon is related to heat concept and photons means it is related to light concept. So we need to incident the light on the depletion region of the this particular photodiode in a different manner also we can able to tell that one. We need to incident the photons on the depletion region. So both cases are same only. So one thing is we need to operate this one under the reverse bias and we need to incident the light on the depletion region. Then we can able to tell it was operated under the required region. Now what are the characteristics and working nature of this particular photodiode we will see. As I said, when you incident the light on the depletion region of the photodiode, then electron hole pairs will be created. Then the photocurrent will be generated. As I said earlier, you need to take the diode is like this. If you take the diode like this, it is representing the PN diode only. But we are talking about the photodiode. So compulsory you have to indicate these arrows. These arrows is representing that we are incidenting the light on this particular structure. Then because of that one, here the electron hole pairs will be created. But this process is going on when you operate this one under the reverse bias only. So how you are giving this battery terminals to the photodiode, that is also important. So this is P type giving to this negative terminal of the battery. N type is given to positive terminal of the battery. So first of all, this diode was under the reverse bias. Then we are incidenting the light on the depletion region of this particular diode. Then electron hole pairs will be created. And these are the two charge carriers for the production of the current. We know from the basics also, electrons are responsible for the production of the current. That current is represented by electron current IN. And holes are also responsible for the production of the current. That current is represented with hole current IP. So both holes and electrons, that means free electrons, are responsible for the production of the current. That current is represented by IN for the electron current and IP for the hole current. And that particular current is due to the incident of the light. That's why we are telling that is the photo current. Okay, already I have mentioned that photo is related to light. That's why it is called photo current because we are not getting the current just because of the external biasing here. We are getting the current due to the incident in the light. That's why this current is said to be photo current. So, in which diode we are getting the photo current is nothing but simply you can able to tell photodiode. And what is the reason for that one? Whatever the current we are getting here, why do we call that current is the photocurrent is nothing but in this case, the current is not just because of the reverse biasing. Here, the current is due to the incident light, incident photons. That's why the current is said to be photocurrent. Now, the reverse current increases with the illumination. That is what we are telling here. How much amount of light you are incidenting on the photodiode, based on that one, the number of electron hole pairs will be created. So, simply we can tell current is related to electron hole pairs, and electron hole pairs are related to amount of light which is incident on the junction. That means the depletion region of the photodiode. If you keep on increasing the light which is incident on the depletion region of the photodiode, then because of this one, you are increasing this one, so number of electron hole pairs will also be increased. So that, and these are the charge carriers for the generation of the photocurrent. So photocurrent is also increased. If you decrease the amount of light which is incident on the depletion region of the photodiode, electron hole pairs will be decreased, so that current is also decreasing. So easily we can able to tell that the amount of the photocurrent which is passing through the photodiode is directly proportional to this light incident or the photons incident on the depletion region of the photodiode. This is what we need to understand. Okay. Then applications are optical sensors and communication. In the communication field also, we can able to use this particular photodiodes, and in the optical sensors also we can able to use. Wherever optical is there, you can able to relate this one to light. And already we have understood that this photodiode is working based on the incident light only, so that we can able to remember that it is used in the optical sensors. Okay.